Hello, everyone. Okay, so thank you for joining. Okay. Wow, so quite a few people today. That's nice. Today is a shortish session, so probably less than an hour, but it depends on how many questions you have. If you have a lot of questions, then might go over an hour, but I'm planning to finish before 7 today. Okay, so basically we have 2 assignments, and let's start with maths. So if you're struggling with anything in maths, or you have a general question about maths, assignment 8, let's keep it to assignment 8. So please do ask, and I will do my best to assist you. I'll probably be dropping some hints on how to do things. So yes, so don't be shy. Fire away your questions, and I'll probably be copying the questions into the into here. Okay. I'll open up the assignments. So assignment 1008. Yep, and physics 1008. And maths 1008. I'll share my screen. Okay. Right. So questions. Happy to answer your questions on maths. Anything, or you can say that you have no questions on maths assignment 8. So I'll know that you don't have. That's also fine. Okay. How did you find maths? Did you find maths easy? Easier than normal? Or easier than physics? Easier than normal. Do other people agree with that? Much easier than physics. Was it easier than normal for maths? Okay. All right, interesting. Okay. I'll probably wait for 1 more minute if there are any questions on maths, and we all can switch to physics. You prefer the more algebraic topics. Okay, interesting. Interesting. I like both. I have to say, I like both. Although when I was your age, I think I preferred algebra as well. Why do we have to draw 2 arcs from the same point sometimes? I'm not sure what you mean. Can you give me a context? What do you mean by that? Two arcs from one point. Same radius? Perpendicular bisectors. Well, if you are doing a perpendicular bisector, okay, so you do when you're doing a perpendicular bisector, so you have 2 points, A and B, and B, and then you have a line connecting them. And then you go to A and you draw an arc from A like this. And then you go to B, you draw an arc from B. And then you go, this is not 2 separate arcs. This is just one arc, but you don't need to draw the whole thing. And the same thing here. You can draw it like this. It's just like for neatness, you do 2 arcs. Problem 5 for the square. Problem 5. A, B, C, D. Well, I mean, you have A, B, A, B. You need a square A, B, C, D. So the square A, B, C, D could either be like this, C, D, or it can go the other way around. It could be C, D, like this. Doesn't matter which one you draw, but yeah, well, do you want to do a perpendicular bisector? You could, theoretically, you could do a perpendicular bisector of AB. I would draw a new point. Let's call it point P. And then I do a perpendicular bisector of AP, and then like this. And then also find this point, and then point Q, and do a perpendicular bisector here. Oh, there are many different ways you can do this, but this is one. I drew 2 points and I drew 2 arcs equidistant in order to draw 2 perpendicular bisectors. Still not. I don't think I'm not sure I'm following you what you mean, Nitish. So as I said, you could do point P and then a perpendicular bisector of AP. Yeah. You could do perpendicular bisector of AB and then find the midpoint. Not really great. Not a great idea. You could find the midpoint, but how do you do that? Oh yeah, you can do that. You just measure, you draw from this, you draw a circle of that radius like this. Find the midpoint, and then from the midpoint, you draw a straight line, and thus you find point C. I don't know, many different ways, many different ways. I did extend the line, draw an arc to double the line perpendicular by say yes, yeah, very good. Okay, let's switch to physics now. All right, so fire away your physics questions. And yeah, happy to help. If you're struggling on any problem, I'd prefer if you had specific questions, but if you just want some guidance on any particular problem, I can do that. Okay. You think you can explain torque? Okay. Torque is pretty much moment. Moment and torque are pretty much the same thing. Moment and torque are the same thing. So for example, if you have a bolt and spanner, okay, so if you apply a force, here, force, let's say 3 newtons, and this distance is 20 centimeters, then the torque is force times distance, which is 3 times 0.2, which is 0.6 Newton meters. Technically, we have a convention that we use clockwise is negative and anti-clockwise is positive. So we could say it's minus 0.6, but you don't have to. You don't have to say it's negative. It's not a strict rule. So that's torque. So when you're talking about an engine, basically what it means. So let's say you have, do I have a motor? Yeah, just give me a second. Okay. So I have a drill, and it has torque settings. So on here, you can see 1, 3, 5, 7, 9. So this regulates the maximum torque it can produce. Okay, so if I put the setting to 1, it produces 1, whatever they measure the torque in. They don't have to measure it in Newton meters, but it actually could be Newton meters. And that corresponds to the force I need to hold it, to prevent the motor from spinning it. So at setting 1, I can very easily hold it with one finger and it will not spin. I'm preventing it from spinning with a very small force. At a setting of 3, it's harder to hold it. The setting of 9, that setting of 13, it gets really, really tricky. It's quite painful to hold it. And at a setting of infinite, well, infinite, it gets quite hard to hold it. So the torque, so you'll need to find the force, you'll need to measure this radius. So suppose this radius is 3 centimeters. So if you have the radius of 3 centimeters, and the maximum torque is 15 Newton meters, that means the force that you need to apply here, force is torque the maximum torque divided by the radius. And that means 15 Newton meters divided by radius, which is 0.0. I said 3 centimeters, 0.03 centimeters. That's what, 500 newtons? Okay, probably not 15 then. Okay, I don't think I can generate 50. Oh, actually 500 newtons is doable. Maybe not with one hand, but yeah, maybe not as much force, but yeah, that's. Does that make sense? Does that understand? Does that clarify things? The torque. Because of course, if I take a lever, so for example, if I take a ruler and I install it here, it would be much easier, as long as the ruler doesn't break, it would be much easier to hold the ruler rather than trying to hold this thing. And vice versa, if I place something inside which has a smaller radius than this thing, it would be harder to hold it. Like imagine I put a pen inside and I try to hold the pen with my fingers. It's much easier to hold here rather than to hold my pen because the radius is smaller. Okay. Sorry, I did quite a bit on the draft assignment. It's fairly different. Just checking through the actual one now. Yes, I need to delete that one. Deleted. Hmm. More questions? If you think about it, when you're talking about engines, the important parameters are torque and power. Well, torque is the maximum force that can produce. Okay, the maximum force that the engine can produce. But we can't talk about force because it depends on the radius of the wheels, for example. If you're talking about a car, if you have a bigger wheel, it's harder to turn a bigger wheel. If you have a smaller wheel, it's easier to turn a smaller wheel. So we talk about torque, which is force times the radius, which is easy, which makes more sense. And power is how much, well, energy, how much work it can do in a second. So these are two different things. They are both very important. So you might have heard that electric motors have a high torque at low revs. At low revolutions, they have very high torque. That's why electric cars tend to start faster than petrol cars, for example. Okay. Well, let's invent a problem. Okay. Invent a problem related to torque. If and the engine, the motor of a scooter has torque 50 Newton meters of an electric scooter. Of an electric scooter has torque 50 Newton meters. So let's do a picture. Electric scooter. Electric scooter. Okay. When the motor, for each rotation of the wheel, the motor does let's say 15 revolutions. The wheel has diameter to 6 inches. What is the maximum incline it can take a rider if the total mass of the rider and scooter is 80 kilograms. Okay. So we have a scooter. It has a maximum torque, and for each rotation of the wheel, the motor does 15 revolutions. Okay, that's reasonable. So the motor spins 15 times, but the wheel spins only once. That means the gear ratio is 1 to 15. Yeah. Sorry. Yeah. Okay. Sorry. Is it 15 to 1 or 1 to 15? I get them confused. It doesn't really matter. The mechanical advantage is 15, right? Mechanical advantage is 15. Okay, so we can find the maximum force in the wheels. So what is the maximum force in the wheels? What is the torque in the wheel? Well, the torque in the wheel is the mechanical advantage, is the gear ratio, multiplied by the torque of the engine. And we see 15 revolutions for each rotation. That means it is 15 multiplied by 15. And that makes it, it's going to be something ridiculous, 15 times 50, which is 750 Newton meters. I think I went overboard with with the torque of an electric scooter torque. Uh, 2.9. Okay, yes, I was slightly off. Okay, so let's make it 5 Newton meters. Okay, 75 Newton meters in the wheel. And the maximum, and I think I wasn't 2, 3, 4, 5. Probably I'll reduce this as well to 5 revolutions. So the mechanical advantage or gear ratio I is 5 to 1. So it's 5. So just seeing the numbers, and I'm scared of what we're going to get. Right, so 25 Newton meters. All right, that's the torque in the wheel. So the torque in the wheel, that means that the maximum force that it can produce against the road, the force, is going to be the torque in the wheel divided by the radius of the wheel, which is 25 Newton meters divided by the radius. And the diameter is 6 inches, so it's 3 inches. The radius is 3 inches. So it's 3 times 0.025. Well, that gives me 25 divided by 0.075, 330 newtons. That's the maximum force in the wheel, right? That pushes the scooter. All right, now let's have a look at the incline. So if you're on an incline and you have forces, so there's a gravitational force which is down. This is the mg force. There's the force pushing you up. That is the force of the wheel. It's actually friction force. And there's a normal reaction force here. And you can see that the mg force splits into components. This is mg sine theta. And this is mg cos theta. In order to go up the slope, the force has to be greater or equal than mg sine theta. Okay. So we know that force is 330 theta equal, m is 80, g is 800 times sine theta. So sine theta has to be less than or equal to 330 divided by 800. So theta has to be less than or equal to, so we take arc sine, the inverse sine of 330 divided by 800, and that gives us divided by 800, arc sine, the answer is 24.6 degrees. 4.6 degrees. That's very impressive for an electric scooter. I'd be surprised if an electric scooter can go up feel like that, but it's a reasonable thing. Does this question make sense? Do you think you could do this question if by yourself? Can I get everyone to answer, please? Would you be able to do this exact question by yourself if I gave it to you right now? Right. And interestingly, even if the engine has a lot of power, if it doesn't have the torque, it won't be useful. For example, if it has enough power to go up a slope, I don't know, to convert so much energy, but it doesn't have the torque, it won't be able to go. So you won't be able to use that power because there's not enough torque to get it to move. If you, yeah. Okay. Any more questions? You have a look on the. Okay. Just in general, hydraulic pistons or in general? Okay. Well, I did last week, but yeah, happy to do that again. Okay, so with hydraulic pistons, you have two different size pistons. Usually, you have a smaller one and a bigger one. The smaller one is the one that you push. You push here, push here. And here, because you're pushing the liquid goes through the pipe and pushes onto that piston. This piston does something useful. Something useful. Okay. And the interesting thing is, because the pressure is the same, pressure in both cylinders is the same. That's Pascal's law. So we have pressure 1 equal to pressure 2. But we know pressure is force divided by area. So it's force divided by area 1. And it's going to be force 2 divided by area 2. Or in other words, F2 is equal to F1 multiplied by area 2 over area 1. So basically what we see here, that it is a force multiplier. F2 is A2 over A1 times bigger than F1. Does that make sense? All right. So you just need to find the ratio of the pistons. But if the piston 1 has radius R1 and the piston 2 has radius R2, we know that A2 divided by A1 is pi R2 squared divided by pi R1 squared. Pi cancels out, so it's equal to R2 over R1 squared. So the ratio of areas is the ratio of radii squared. So this is a useful thing you can use. You don't have to find the area. You just take the ratio of the radii. So if we look at this system that is here, so we have a force applied onto this cylinder. So there's a force here, F1. Well, that's not F1 because this is F1. This is the force we apply. It gets multiplied by this lever. And then there's F1 applied here, F1, A1. But the pressure in the piping is always the same. So the pressure here, P1, is equal to P2. And we know that the radius of this cylinder is diameter is 2.5. And diameter here is 0.5. So F2 is equal to 2.5 divided by 0.5 squared multiplied by F1. So that's this force F1 is multiplied by this system because this is a bigger cylinder than this. And for the last question, I've pretty much done a very similar question last week. So do watch the webinar from last week and hopefully that will make sense. For problem 14. Okay. But I think if you understand the logic, the underlying logic, then you can start making sense. Oh yes, for the power torque thing. The electric vehicle power torque. So here you can see that power is 2 pi tau f, and tau max we already know it's 400 Newton meters. And you can see that the torque is maximum at the beginning. But then once you reach maximum power, because power depends on torque and frequency, right? And once you reach the frequency at which you have maximum power, the power stops increasing, like the power levels off. So we have torque is now equal to power divided by 2 pi times frequency. So we have the torque is inversely proportional. So torque is inversely proportional to frequency. And this is what you can see here. All right. So it's 1 over F. Tau is proportional to 1 over F once you reach maximum power. Right? Does that make sense? So at first tau is 400, but then basically you kind of power linearly increases with f up to some point. So at first, power is proportional to frequency. That's frequency. Yes, that's frequency here. So power is proportional to frequency until it reaches the maximum value. Once it hits the maximum value, now power is constant, roughly constant, but then the torque now decreases because torque is inversely proportional to the frequency. Right. Okay, then I'll finish here for today. I hope this was useful, and I'll see you next week for some more stuff. All right, enjoy. And enjoy the weather this week, of course. See you, everyone.